Say hello.
Hey
So we're gonna put waffle right here.
everyone, welcome. Today I have Yuri from Shure Microphones. I'm really excited because we're going to be doing a deep dive into the technology behind the Nexadyne Microphone Series. So, hi Yuri, how you doing?
I'm doing great. Thanks so much for having me. This is gonna be so much fun.
Yeah, thanks for coming. I'm like really excited to nerd out. I
Mm,
have a bunch of questions here on my computer, so if I'm like looking over here, it's because I'm just looking
yeah,
at the questions. But why don't we start? Why don't you start by introducing yourself and telling us a little bit about like what you do at Shure and whatever else is applicable?
yeah, absolutely. So, hey everyone, my name is Yuri. I've been at Shure for a few years now, and my job is to essentially be a product expert, so to speak. I basically go around, travel, go to conferences, make online presentations, do things like this, hang out with Kato on her show, which is awesome. To talk about like how cool our stuff is. I educate people how to use our products. My areas of expertise are microphones and small to mid-tier wireless systems. I'm kind of working my way through high-tier wireless right now. I'm certainly not at the level yet to be doing any kind of trainings on them, but I just got my ADPSM in the mail. That's our new Axion digital IAM system,
Oh, cool.
and I haven't even taken it out of the box yet. I'm scared to take it out of the box, but that's the next thing that I'm going to learn. So I have the best job in the world. I get to travel and talk about gear for money, which is what I would do for free anyway. So it's great. So I'm
Yeah,
so happy to be here.
that sounds like so much fun too.
Hmm.
So the Nexadyne series, that's a new
Hmm.
series that you guys just unveiled. Was it at NAMM that you unveiled it or?
Yeah, so the Nexadyne vocal mics have been out for about a year. So I'm speaking
Okay.
into one right now. So this is
Yeah.
the NXN8 cardioid version. Is it the cardioid? Yes, it is. So I'm speaking into the cardioid one right now. We also have a super cardioid. So that's been
Mhm.
around for about a year. We started out. I was running around festivals like Lollapalooza and Austin City Limits and throwing it at whatever artists want to try a new microphone and. People fell in love with it. It sounded great. It worked really, really well on stage. We'll talk about the tech behind it as to why it's so awesome. And then the original plan was to make an entire line of microphones kind of sitting in between our beta and our KSM premium line. So, yeah, so at NAMM show this year, just a month ago, oh my God, it's only been a month. Jeez.
Yeah.
It feels like such a long time ago now. Yeah, we released our next set of Nexadyne mics, which is the kick drum mic, the tom and snare mics, and then the guitar mic as well. These
Awesome.
these folks right here. Yeah.
Cool. And I saw online you have like a tagline for him, right? It's more of what you want, less of what you don't. Is that
Yeah.
correct?
Yeah, we started using
I
that
did
for the
my
vocal mic.
research.
Yeah. It's cool. I don't choose our marketing type, so I'm glad that people like it. But yeah, basically the idea behind it is the technology, it's a patented technology that only we have. And I'll show some diagrams in a little bit where you can see that like the rejection in this microphone is like true rejection across a wide range of frequencies, which is not a lot of times people will say their microphones are super cardioid, but I
Mhm.
always follow up with like super cardioid at what 2000 hertz 10,000 hertz,
Right.
like if you really like dig down into a polar pattern of a microphone you can see where they're super cardioid, maybe where they're a little bit more cardioid. Low
Mhm.
frequencies they tend to become a little bit more omnidirectional. Our mics
Mhm.
are not our microphones are not privy to that either. Like we have a couple of microphones that do go omni in the low frequencies, but this new technology on these Nexadyne mics, it keeps that polar pattern so consistent across so many frequencies that like when you put it on stage, you can feel confident that you're getting, we say more of what you want, more of you, and less of the surrounding stuff that you don't want.
Cool. So it's like more
Yeah,
stable in that sense.
exactly. Yep.
That's so cool. So that's because you have was it the dual transistor or transducer?
Yep.
My brain, sorry.
Exactly. But it's all good.
Transducer because it's converting energy, right? That's the two capsules, isn't it?
Right. Yeah. Each of our
Okay.
Nexadyne microphones have two actual working dynamic transducers inside them, which is just magical. And
That's
I
so
can show
cool.
some diagrams about that too. Yeah.
Yeah, I do. I have questions because I
Please.
was looking. Okay, I was rewatching the video that we took at NAMM, which is
Yeah.
in one of my past videos. I'll link to it down below if people want to see it. But you were
Hmm.
talking about the dual capsules, and then you were talking about how the electrically flipped, right? That's like
Hmm.
polarity flip. Is that
Yep.
correct? So
Correct.
electrically flipped, but acoustically coupled. So in terms of
Correct.
vibration, it's the same, right? And I was wondering, I was thinking about like balanced versus unbalanced cables. Are you essentially doing what a balanced cable does to cancel noise? Like, do you
In a
flip
sense,
the
yeah.
polarity and then unflip it on the other end, and then it
So no,
helps?
there's no unflipping. So it's not exactly like
Okay.
a balance cable. It's more like a humbucker,
Okay.
where you're basically just literally flipping the two channels that you have and calling it a day.
Okay.
Yeah, it's so cool. No, yeah, there's definitely no flipping on the other end. So it's not like we're not removing RF noise that is like feeding into the cable or
Okay.
anything like that, which is how balance cables work.
Yeah.
So it's much more of a these two capsules are not acoustically. I have to be careful with my words. They don't acoustically function the same way.
Okay.
So like let's get into it.
Yeah, yeah,
I can
yeah,
get
do
right
it.
into it. Yeah, absolutely. So can I do a little bit of a history lesson? Is like
Yeah.
how sleepy are your fans gonna get if I talk about
No,
history?
I'm game,
So
so
awesome,
they can
awesome,
deal, or they can like it, or they can whatever.
awesome. Yeah. Well, the Nexadyne
I'm here
story
for the
started.
nerds.
Yeah, nerds.
Yeah.
Thanks for watching, nerds. Love you guys and girls and
Give us
everybody
a
else.
good, like, Nexadyne history bedtime story,
Yeah,
like, back in the
absolutely.
day.
So it's a cold winter day in 1966, and one of our engineers, Ernie Sealer, is working on a new dynamic vocal microphone. So
Mm,
I don't know if it was the winter or not, but basically what happened was when we came out with the SM58, which everybody knows the SM58, it's our most
mhm.
popular microphone. This microphone came out in 1966, and it was the first real serious experiment with using a handheld dynamic microphone. And dynamic
Okay.
microphones have problems. The main problem with a handheld dynamic microphone is that it's going to get a lot of handling noise.
Mhm.
The way dynamic microphones are made, they resonate in like between like 100 hertz to about 800 hertz, which means that that's like prime handling noise frequency, right?
Yeah.
So condenser microphones do not have that problem. So like if you're using a condenser mic on stage, you'll notice that the handling noise is considerably less than a dynamic microphone because they resonate in the much higher like
Mhm.
10K or whatever. But so there has to be a solution put in place to make dynamic vocal mics work and not have a ton. I was about to swear an S ton of hand. I don't know if I'm allowed to swear
I
in this
I
program, but I
think you're
probably
safe
shouldn't.
for swearing now. It's like the first however many minutes you're not supposed to swear, and
Oh, is that
then
what it is? Okay.
I think you get
Um,
tend to get away with it past a point, but I
Gotcha,
usually
gotcha.
don't swear, but,
No, no. So
a
I'll avoid
ton.
it. A ton
On
of
camera.
handling noise. And so what happened was like every company has a different way of doing it. The most common way is to actually build a physical like shock mount, like some kind of piece of rubber or something, some kind of
Right.
mechanism, like an actual shock mount like this.
Yeah.
Um,
It's
that
like the little
like
hair ties.
yeah, exactly.
Yeah.
Something that tries to separate the capsule from the body of the microphone, right? And they have varied results. Sometimes they work really, really well. Other times, maybe not so much. They're far from perfect, right? There's
Mhm.
also some other microphone companies that I think do like active cancellation, like they actually have circuitry and
Mhm.
DSP built into their mics to kind of knock it out. And we decided in 1966 to do an acoustic solution to that. So I'm going to share. This is this is also why the SM58 is the greatest microphone ever made. All right. So this is the actual patent. This is not private information by any means. This is a
Okay.
public patent,
Cool.
as all patents are. Talking about so you can like go to the patent office and look at this or whatever, or our website. It's on our website. So this
This
is
is
the
so
original.
cool.
Yeah, this is the original patent for the design, the acoustical design of the SM58. We have a couple of other patents for the actual physical design and some other stuff. But here's how the acoustics works. And there's like this long, long description of like what this microphone actually accomplishes. And
Mhm.
so this is a cardioid microphone. So what happens is back here behind the diaphragm, there's like an air chamber that allows air to flow into the back to make it cardioid. I don't know if we're going to talk about the details of how a cardioid mic works or not, but fun fact, by the way, we invented that in the 1930s, which is super,
Nice.
super cool to talk about. We had engineer Ben Bauer who invented this using ports in the back of the microphone to allow air in and hit the back of the diaphragm like
That
that.
is so cool, and that's still something that, since you have the patent, right, no one else is doing?
No, no. That is a technology that everybody uses now. So
Oh,
like
okay, okay.
every single, I can't think of a single cardioid microphone that does not use ports to achieve what it does.
Okay.
I think that's like across the board. The only other way you could really do it is by like combining two microphones together and then making them cancel each other out, which is how it was before we invented
Oh, wow.
this way. Yeah. I'm talking like I'm taking credit for this awesome invention that happened in the 1930s, right? Like Ben Bauer was a genius. And Ernie Sealer, this engineer, was also a genius. So in this giant network of stuff, like the number 44, for example, 46, like this whole thing, there's actually a third air chamber behind here.
Oh, wow.
And this took uh, a, over 200, I want to say 228, I don't remember the exact number, but over 200 equations to create this like finely balanced system of like air pockets and air chambers
Mm,
back here. So we call this the pneumatic shock mount.
that's the patented thing.
And that's part of the patent, yeah.
Yeah.
And no one else can do it, not because it's patented, but because nobody knows these equations. Like these
Okay.
are tucked away. I don't know them. These are tucked away in our engineering department in our archives,
Yeah.
and only the engineers have access to them. But these basically, there's a couple of air chambers in here that work as kind of like a mass spring system, so that when you hit the microphone, when you vibrate the actual physical microphone, the air here, the air pressure here changes in a way that keeps it from getting to the diaphragm.
Hmm.
So it's a shock mount using air pockets rather than like rubber or some kind of other material that just tries to disconnect it from the body of the mic.
Hmm.
And it works so well. And like no microphone even comes close. Like the shock mount technology in the SM58 is just so good. And there's like a whole set of this whole thing here. The right side here talks about how it actually does what it does, which is just
Mm,
fascinating.
that's
And
cool.
back here as
Can
well.
you send me
So
this?
yeah, absolutely.
Is there
Yeah,
like a
no
link
problem.
for it?
There is a link for it, so I can
Okay.
share it with you.
That'd be
Absolutely.
cool. I'll put it in the
Yeah,
description too if anyone
yeah,
wants to.
absolutely. And again, this is not like privy to Shure. Like I got this from our website. So
Right.
um,
You're
so
not
yeah. So this is
spoiling
just
anything you shouldn't.
nope, nope. You're
That's
not
cool.
you're not going to be able to recreate this. You know what I mean?
Yeah.
So this has been our shock mount in every single dynamic vocal mic that we've made. So the Beta 58A has the same, the KSM 8, which I'm going to talk about in a second. You probably can't see it because you're still looking at the patent.
Hmm.
But the KSM 8 has the same adjusted shock mount because it's a different body of a microphone. So you had to redo all 228 equations to make them work for a new body mic of a mic,
Hmm.
right?
Yeah.
So those are our three vocal dynamic microphones that have the shock mount. And with Nexadyne, so Nexadyne started out as an experiment.
Hmm.
One of our engineers, Roger, was like, "Hey, you know what? Let's see if I can find a way to like minimize handling noise without doing these 200 plus equations every single time we come out with a new microphone, right?"
Hmm.
So that's how Nexadyne started. And as you mentioned, basically the way it works is, let me see if I have this one here. There it is. So, well, I'll get to that in a second. But basically, there are two actual working diaphragms, not working. I'm sorry, working capsules, like two dynamic microphones built into one
Hmm.
body, right? And they feel the exact same vibration. So they're completely in phase when you hit the microphone, right?
Okay.
But then, as you said, the output of them is out of phase. We reverse the polarity of one of them of the rear diaphragm or
Hmm.
the rear capsule. I keep saying diaphragm, but it's not just a diaphragm; it's a whole capsule.
Yeah.
The We'll call them motors because that's what we call them in the engineering world. So you flip the polarity on the rear motor, and it acts as essentially like a humbucker for vibration. You get rid of whatever in phase vibration happened into the microphone. I
That's
will
cool.
say I have to be honest, it's not actually as good as the pneumatic shock mount.
Hmm.
The SM58 still wins as far as defeating handling noise, but I mean,
Wow.
here I am talking into it. This is the extent of the handling noise that you're
Yeah,
gonna
and that's
hear.
pretty serious abuse with
Yeah,
the
like
tapping
I'm
it like
really
that.
hitting this microphone, right? So
Yeah.
like, it's not bad.
Yeah,
And
that's pretty
I'm
good.
not EQing my input or anything like that. So what you're hearing is what you're hearing.
Hmm.
Um, so it works. It did a really good job. So that's how it started.
Okay.
And we learned a lot about this because of the KSM 8 microphone, which is, where is it? So this is another genius invention of ours. This is the KSM 8 microphone, which came out, I believe, in the 2015 or so, something like that, mid 2010s.
Hmm.
Um, and this is our before the next time. This is our latest and greatest dynamic vocal mic, and this has one working motor, which is right here, where it says
Okay.
active front diaphragm, and
Hmm.
then it has a passive diaphragm in the back, which its only job is to kind of be a resistor for the air and to control low frequencies and like manage proximity effect.
Okay.
Um, so this microphone is like super cool. It does two things. Number one, it has a very consistent, relatively wide cardioid pattern, so I can kind of like sit around the microphone a little bit and still keep the tone of my voice relatively consistent.
Nice.
And it also minimizes proximity effect. So this is one of our engineers, Roger, who's a genius. I will tell you honestly, I have asked him to explain to me how it does it several times, and he's tried, and
Yeah.
it's not his fault. It's my fault, and I still don't quite exactly understand what magic happens inside this microphone. But I know it's part of it is this. There's like side ports on the side, and
Hmm.
the air actually flows in from the back, hits a reflector, and then flows back down into both diaphragms.
Huh.
Which like it's magic. I don't even know. Like I'm studying acoustical engineering for my master's degree right now, and I cannot legitimately explain to you the acoustics of how this works yet.
That's
Um,
wild.
and maybe one day we'll get Roger on the show and he can talk about it for a while. But he's still at Shure. He's brilliant. Love that dude. Anyway, so that's the KSM8. So starting with the KSM8, Roger was like,
Hmm.
okay, we now have a microphone that has a one working dynamic capsule or motor and one passive diaphragm. Let's
Right.
see what we can do with two active motors. So
Yeah.
Nexadyne was a Roger project, and um, so thank you, listeners and watchers, for bearing with the technology aspect of all of this stuff. So here's Nexadyne, and let me see if I can share this. So now we're looking at what Nexadyne looks like on the inside. And this thing is just absolutely magical, right? Here's what it looks like on the outside. So this is like the Nexadyne kick drum mic, which uses the same technology as the vocal mics. And this is what it looks like on the inside. You have two capsules, and in fact, one of them is a relatively wide cardioid. This one here. So, and there's like an air opening back here to let the air in. And
Okay.
this here right now, the back one here is actually omnidirectional. There is no air opening for this one. So it's truly omni. And then this is the one that gets subtracted from this one. So we're taking like and the way it works is just again, it's freaking magic. I love this technology, right? So as you said from the beginning, they're completely in phase when you hit the microphone. So they're
Hmm.
attached to the body of the microphone the exact same way. This guy here, this back motor, is subtracted from the front motor electrically.
Okay.
So we're just switching the polarity of the signals. But here's the magic, like the real magic behind these microphones is that they're sharing the exact same acoustical space.
Hmm.
This one has some openings behind it. This one does not. There's a big opening between the two. Well, now it's not that big. It's like right here. So
Hmm.
it's not that big.
Big for a
Uh,
microphone.
exactly, yeah. And there's like some damping material. That's what these R's and C's are. C's like a
Hmm.
compliance, R's a resistance.
What kind
Um,
of material is it?
I actually don't know. Probably some kind of felt or felt like
Okay.
material. That's the most common way to dampen things in microphones.
Hmm.
I don't know the exact material, but that's not. It's not a trade secret. I just don't know it.
Yeah.
But it's some kind of felt material. That's like a lightweight cloth type thing,
Cool.
and uh, and they're arranged in a way to kind of work together. So what happens? The magic that happens when you subtract this omni signal and this relatively wide cardioid signal from this wide cardioid signal, and while they're sharing the same acoustic space, you still get a functioning polar pattern, right?
Hmm.
And by making changes to this airspace and to the damping materials and where things are, we can actually make it very, very consistently cardioid and very,
Hmm.
very consistently supercardioid, or really anything in between if we wanted to. It's just a matter of changing these parameters. And the magic is that these two motors are working together, and one of them is being subtracted from the other one. So super, super cool technology. Like I absolutely
Yeah.
love it. You're hearing it right now. I'm talking into a Nexadyne microphone, vocal microphone right now, so you can hear what the cardioid sounds like. And like what I like to brag about. Here's the tom mic. So if anyone wants to see what the tom mic looks like, um,
And this
oh,
technology allows them to be smaller. Is that, I think I saw that somewhere, or is that not
yeah,
true?
you can control the volume of this. You just need whatever requisite volume to make it work.
Yeah.
So you can make them pretty small.
That's
Yeah, you
cool.
can squeeze them pretty closely together. And again, and these are dynamic microphones, which there are limitations to how small you can make dynamic microphones because
Yeah.
you need space for the magnets, you need space
Yeah.
for the air, like the air spaces, like but you can make them smaller than typical one diaphragm microphones if you want to. Um, sorry, one motor microphones. All right, so here's what I want to show. Here's our kick drum mic, and I'm not gonna I don't talk about our competitors. We're not allowed to talk about our competitors. So
Hmm.
people can do their own research, look up the polar pattern of your favorite kick drum mic, including the
Hmm.
Shure Beta 50A, Beta 52A, right? If you look at the Shure Beta 52A, it does not look like this.
Hmm.
Like this is the fact that we've kept it so consistently super cardioid from 250 hertz up to 10,000 hertz is just insane.
Yeah, that's
Like
wild.
Yeah, like even if you look at the Beta 52A at low frequencies, it becomes relatively omnidirectional. So like, if you've got low end on stage, it's going to come into the rear of the Beta 52A.
Mhm.
And some other competitor microphones. But this one, when we say super cardioid, here it is. Like
Mhm.
it's pretty fantastic. And this is really just those two motors doing that kind of work. Here's our tom mic.
Mhm.
They're all super cardioid. All of the instrument mics are super cardioid. And here is our guitar mic. And you can see how
Wow.
consistent it is. Like that is just insanity. To me, it's like magic that we were
Yeah.
able to achieve this. And then, the vocal mics, here we are. This is the cardioid vocal mic that I'm speaking into. And the super cardioid microphone is right here. And you can see even the vocal mics keep that consistency going
Wow.
across a
So is that
wide range of frequencies.
is that how is this like the primary way, I guess, that these then reduce like bleed from other instruments on stage?
Yep. Yep. That's the magic is the two motors make it work so consistently.
That's so
100%.
cool.
Yeah. And that's why I love them. Like I think when people look at Nexadyne, they look at it and be like, "Oh, cool! Shure came out with another
Right.
new dynamic microphone, and it's like over $200. Like, what's the deal? Like here's the deal. Like this is how awesome they are."
Yeah.
um, and they're a brand new microphone, so people haven't had that much of a chance to experiment with them and mess with them and like really get it.
Right.
Um, but like, man, Usher used it at the Super Bowl. Like we're
Oh,
putting them
nice.
on stages now, and I'm hoping this is going to be the next big thing because they sound unbelievable and they reject so well, even compared to other microphones that we've made in the past, which is just
That's so
awesome.
cool.
Yeah, and
It's
that's
wild how like technology has such a big influence on the art, you know? I don't
absolutely,
I'm biased, but
yeah,
there's
absolutely. And
something
I
there
think
that I think is really exciting.
honestly, that's probably one of my favorite things about working for Shure is like we're continuing to innovate acoustically. Like pound for pound, like microphones have been solved. Like,
Mhm.
you can make a microphone. We generally know how they work. But the
Yeah.
fact that we can still make like a KSM-8 and these Nexadyne microphones and continue to like innovate and just make them better using acoustics is like
Yeah.
it's magic. Like I
Yeah.
absolutely I keep saying that word because like I'm just learning how all this stuff works and it is just unbelievable how smart our engineers are. And I'm just so
It's so
happy to be
cool.
working there. Yeah.
Because you think like I think a lot of people kind of, whether subconsciously or consciously, are like, "Oh yeah, we've figured it out,"
Mhm.
you know. But then you think about how much it can keep progressing after this. I'm like, what's it going to
Yeah.
look like in 20 years or 30 years or
Yeah,
I don't
absolutely.
know.
Yeah, so like, yeah, I don't know what the next innovations for microphones are going to be in the 20 years, but I'm quite confident that Shure is going to be a part of that innovation. So,
Yeah, that's cool.
and hopefully I'll still be around.
Would you say then that these mics are definitely designed more for a live setup than a studio, or are they like dual purpose?
I would say they're dual purpose. I think naturally they're more inclined for live.
Yeah.
And partially it's because with studio with controlled environments, you have so many other choices.
Yeah.
Um, the rejection is important, especially if you're going to use the tom mics. Having like really good rejection on tom mics is really good. I know that in my opinion and generally how we're marketing them is for both live and studio, but the early adopters of all of this technology are the live folks right now.
Okay.
So we're hoping to get them in some studios and have some fun. Especially like I don't have a favorite child, but I kind of do have a favorite child. Like of all of the Nexadyne mics,
Hmm.
this kick drum mic is essentially like my favorite child of the ones that we made, and it sounds first of all, it sounds unbelievable. But generally speaking, like a lot of times when people mic up our stuff, either in the studio or in live, they'll have like a Beta 91A inside the kick drum, and then they'll have a Beta 52A on the outside of the kick drum, and then they'll
Hmm.
combine and mix and match those signals to make it sound however they want. This one, you just put it in, and it does the job of two microphones essentially.
That's
And
cool.
it's sounds so good. So like as far as studio adoption goes, I could see the kick drum making a huge splash in studios.
Yeah.
With snare mics and tom mics, there are a lot like these are specialized with snares and toms. You don't really have to have a specialized mic. You can kind of use, whatever.
Hmm.
That's different for live. For live, you need relatively specialized microphones. But for studio, I hope our tom mics take off, and I hope people use them. The cool thing is like the technology is it works on anything. they're tuned a little bit differently from the vocal mics, but like I've taken this vocal mic and I visit a bunch of colleges every year and I do like
Hmm.
recordings with them and stuff. And like I've put this on snare and I've put this vocal mic on percussion and some other stuff. I'm like, it sounds great. like
Yeah.
like it works wonders.
That's like taking the 57 and putting it on.
Right? Yeah,
Like that happens all the time.
exactly. And people I've heard recordings with 57s on God knows what, and
Yeah.
sounds good, right?
I've started like recommending to people too. I get a lot of people
Hmm.
asking me, what mic should I get, for my space or whatever. And I'll be like, have you treated your space acoustically? And
Hmm.
if not, then I'm like, oh, well, maybe you should just get a 58, honestly.
Yeah.
If like you're starting out and you haven't treated your space and it's going to be nicer to you.
Yeah. Yep.
Yeah.
I mean, generally speaking, like a dynamic mic is better for bad spaces
Yeah.
than a condenser mic. Not because they're of their sound, but because they force you to get closer.
Yeah.
And you know this. The closer you are to
It's
the
like a little more
microphone,
forgiving.
yeah, more of you, less of the space, et cetera, et cetera, et cetera.
Hmm.
But like, yeah, the same thing. I recommend, if somebody's looking for their first mic ever and they're just on a budget and just trying to do something, I always recommend the 57.
Yeah.
Like, top
It's a good
notch.
one.
If it's mostly vocal stuff, then probably the 58. If they have the money to spend on a more professional like podcasting recording mic, I would obviously choose like the SM7B or SM7DB.
Hmm.
But I don't always recommend that as somebody's first microphone. Like maybe spending the $100 on the 57 and just getting really comfortable with how microphones work in your
Yeah.
environment is much
Learning
more
it.
useful than throwing down $400 right away and going from there. But
Yeah. I think so too.
yeah.
Yeah.
But yeah, we have all sorts of studio mics that I love, and Beta 181s, just beautiful microphones. KSM
Hmm.
32s sound great on everything. Like, you know,
Yeah.
I can talk about those forever.
I love it.
Yeah.
You said something in the last video when we were at NAMM, and then also a minute ago you were talking
Mhm.
about the two capsules, right? The two motors.
Yep.
The
Two
two
motors. Yeah.
motors, and how it's kind of like those enable you to kind of have a blend of the sound of two microphones combined, right? Two specific ones. Is that correct? It's like
This
as if you combine this mic with that mic.
Yeah, I think that's the case with this microphone right here. It's more
Yeah.
just the way it was tuned, but yeah. The two motors primarily allow you to control the polar response in a
Yeah.
certain way. As far as like frequency response goes, like how it sounds, that is, it has to do with other things.
Okay.
Having the two motors does make it a lot easier
Yeah.
because you get more control. But generally, the two motors are working more towards the polar response and the frequency response. That being said,
Okay.
though, there is some truth to that, and it's just like, and I don't know, like I'll have to look at the frequency response of this microphone. I don't have it memorized, but it just
You don't
does
have
it.
it memorized.
I don't.
What
I don't.
gives?
I know, right? I can pull it up if you want. But that's the other thing. Like
Yeah.
frequency response charts, they can be also a little bit misleading.
Yeah.
Only in the sense that that's not how we hear things.
Yeah.
I think a lot of people, when they look at the frequency response of a mic, they'll see like tiny little specks here and like a little dip here and a little, especially in the high frequencies when that happens.
Mhm.
Like you don't actually hear that when you hear a microphone because like we group sounds in octaves and third octaves to some
Yeah.
extent. So like those little tiny things that happen at specific frequencies, unless like it's a really big peak or like a really big, drop, it's not likely that we'll be able to hear it in the grouping of the frequencies around it as
It's
well.
like we
So
hear it as a textural thing, right?
exactly, yeah. So we have to
Yeah.
we have to kind of take frequency response charts with a grain of salt, especially in high frequencies.
Yeah.
At least
That's
the
interesting.
details of them. Yeah.
That's a good point.
Yeah, and that's microphone agnostic. That doesn't matter if it's a Shure mic or an AKG
Right.
mic or whatever. It's just
Right.
like it's just the way we hear.
Yeah. So I had a question. Maybe this is not as relevant based on what you just said, but
Hmm.
I was thinking with that, like, oh, it sounds like this mic combined with that mic idea.
Hmm.
Is the next step to have something where it's like you can order a customized mic where it's like a blend of these two other Shure mics that you like?
Ooh, interesting. That's a good idea. I'm gonna take that back to the engineers and see what I can
Thanks.
do with that.
All right, everyone. Future Cato here. I am editing right now, and there's a little break in the conversation here. So I wanted to just jump in and say hi. Welcome to my channel. If you haven't yet, please subscribe. We talk about audio engineering, music production stuff, and we have a lot of fun. It's pretty nerdy. So please subscribe if you haven't already. Okay, now back to a part of the conversation where we're talking about acoustic signal processing.
I get that question a lot. Like, what does it mean when this dual transducer technology does acoustic signal processing? And it's literally the stuff that you and I just talked about. It's
Yeah,
the
the
it's the
airflow and the
exactly, and the subtraction of one from the other one, and then the
mhm.
combined airspace, acoustic airspace, causing these two capsules, these two motors to be working together to get the
Mhm.
result that you want.
It's not like a DSP
Exactly. We're not using any
processing.
DSP. It's all done acoustically, and it's super, super cool.
Awesome.
Yeah.
I had one random question
Yeah.
that's not related to this. I had a video a while back, and I think I emailed someone at Shure. I don't remember what it was, but
Hmm.
it was about the 55 SH, the 57, and the 58. Because I was
Okay.
told, I just wanted to confirm. I know I confirmed it via email. I don't know why I need to check because people give me trouble about this.
Hmm.
Um, about the differences between them, right? And my understanding was the 57 and the 58 are essentially the same, and it's
Hmm.
the actual the grill, right? That's the difference.
Yep.
Is that true?
It is. So the 55 is a little different.
Yeah.
They're all three microphones are based on like the Unidyne concept, the Unidyne
Yeah.
capsule, but they are different microphones, especially compared to the 55.
Yeah.
The 55 is kind of its own animal. It does use the Unidyne principle, where the 57 and the 58 are based on that,
Mhm.
but they are different microphones.
Okay.
If I'm comparing the 57 and the 58, they're essentially the
Right.
same mic.
I was
That being
told
said,
that literally if you swap the grill, you've essentially changed them into each other. Is
that's
that
not exactly
accurate?
true. That's
Oh,
it's relatively accurate, but it's not 100% accurate.
okay.
Because there is a change that happens. So the 57, the I wish I had I have a 57, but it's not in the room right now. It's in the other room.
Oh, I have a
Um,
58.
you can open up the 58 if you want. So the 57, the grill and the resonator right behind the grill are like directly connected to each other and embedded into the rest of the body of the microphone. You can't
Okay.
technically, I mean, you can, but you technically you're not supposed to be able to unscrew the grill from the 57 because
Right.
it's like integrated into the rest of the microphone. Um, Whereas in that
Weird.
case, obviously you just took off the grill and that is not integrated into the body of the microphone. So there actually is a slight frequency difference between the 57 and the 58
Okay.
because of that integrated resonator grill assembly on the 57.
Oh, okay. So it's like
Um,
related to the grill, but not
exactly.
the grill.
Other than that, they're exactly the same microphone.
Okay.
I think the difference. I don't want to lie to you. I think the difference is at 5 kilohertz. You're going to
Okay.
get a little bit of a bump at 5 kilohertz on the 57 that you're not going to get in the 58 because
Okay.
of where the resonator is placed.
Cool.
Yeah.
And then the
That's-
55, because the myth is that the 55 SH, the 57, and the 58 are like all essentially the same, but
no, the
it's the
55 is
grill that's the
different.
difference. But I know the 55 is different.
It is. Yeah.
I
And we
forget
have two different.
how.
I don't know the technical difference. The capsule is very similar because they're
Yeah.
all three have Unidyne capsules.
Yeah.
But then you can make the case that the SM7B also has Unidyne capsules. Is that the same as the 50? It's
Right.
definitely not,
Right.
So the capsules are designed a little differently. They're tuned a little bit differently. Obviously, the body of the microphone affects the sound of the microphone quite a
Right.
bit. So that's a little different, but they're not. I can't open up a 55 and make it a 57. Like it just would not work the same way.
Right. Okay.
Yeah,
Cool.
that's
Yeah.
a great
I'm glad
question.
I
I
asked you
love.
because that expanded my understanding from last time.
Yeah,
So
I love
I'm
getting
glad
those
I
kind of
asked.
questions. Yeah, they're fantastic. And like in a worst case scenario, you can unscrew the grill of the 58 and use it as a 57. You're just not
Hmm.
going to get exactly the same high frequency resonances as the 57 because of the way the resonator's set up in that microphone.
Okay. So it'd be like a custom thing that you did.
A little bit, yeah.
It's fun.
But it's interesting. I don't. Most people don't know that dynamic microphones have resonators built into them, but they do.
Yeah. That's cool.
Yeah, because you can't. If I just take a dynamic microphone and don't put a resonator in, it like drops down at about 10K or less.
Oh, wow.
Yeah, like it's a significant high frequency drop. So
Wow.
I'm not going to say all dynamic microphones, but I would say most will have resonators built into them to kind of give them a little bit more of a high frequency boost.
Huh.
Uh,
That's interesting.
yeah,
That's
and that's
cool.
not a Shure specific thing. It's just a general dynamic mic thing.
Yeah. Yeah. Cool.
Yeah.
So would you like to do any social media shout outs, website shout outs, anything like that?
I mean, I don't have any specific shout outs that I can think of. If people want to follow me personally on social media, my Instagram is Yuri Music, Yuri Music. It's going to be mostly Shure and audio stuff, and then a little bit of Waffle, my cat, and which is very, very enjoyable. Other than
She's
that,
cute.
she's awesome. I love her. Um, Other than that, check out the NXN mics. Go to your local dealer, go to your rental house or whatever, give them a try, put them up on stage. I think you're going to be very, very pleasantly surprised at the sound and the rejection that you get out of those microphones.
Sweet. And I'll put links in the description below, and I'll have a bunch of other links for the stuff that we
Awesome.
mentioned throughout this video.
Yeah.
And thank you so much for coming on.
Thanks so much for having me. This was so much fun.
Okay. I had a thing about the Revonic dual engine transducer technology, but that's like what we
Which,
talked about. I
yeah,
just
we
like
talked
that
about it.
phrase. I
Yeah.
just wanted to say that phrase, to be honest. I just wanted to say it.